Okay, number 94. You're driving a car. You slam on the brakes. You skid. What's coefficient of friction? So, boy, this one's really going to need a picture, I think. So, you got a car. What do they tell you? It's 2,500 kilograms. It's got a speed of 14 meters per second. You slam on the brakes and the wheels lock and you skid to a halt. So you're going pretty fast, and then you slow down, and it tells you this distance is 25 meters. Boy. What is the coefficient of kinetic friction? Now, the only way for us to find the force of friction, or the coefficient, is this equation. It's the only way. So, in order, because number 94 is looking for what is the coefficient. We don't know this. And the only way possible to get that is you got to know the normal force. We could probably do that now, and we got to know the force of, so we have to find, these are our secondary necessities. We need to find both of these first, then we can find the coefficient. So the normal force is probably the easiest one, because you go back to our car, the force of gravity is pulling this thing down. You got to take 2,500 times 9.8, and that's 24,500 newtons. That's actually, since this is an inclined plane, the normal force, 24,500 newtons. So there's my normal force right there, 24,500, like that. Now I got to find the force of friction. Now friction will be a little bit trickier. These are my velocities, you know, but what forces are acting on this car, I guess I should say. You know, once you start applying the brakes, the engine isn't driving, so there's no force pulling this car forward. There's only a force pulling it backwards, and that's the force of friction. Now, what we're gonna do is use F equals ma, and we'll use the net force. And the net force is friction because there's nothing pushing it forward, so the net force is actually friction. The mass of this car, 2,500, and the acceleration. Now the acceleration, what we're going to have to do is all of this given stuff. We know that the initial velocity is 14.0 meters per second. We know that the final velocity is 0.0 meters per second. We know that the distance is 25.0 meters. And we could probably find the acceleration from that stuff using the only one that doesn't have time. So Vf squared equals Vi squared plus 2AD. So final velocity 0, initial velocity 14 squared plus 2 times acceleration times distance, which is 25. So 14 squared, 196 plus 50A. So I move this over. The acceleration is just 196 divided by 50 is 3.92. So that's there's my acceleration. So I can find that force of friction. 2,500 is 9,800. So friction's pulling this thing back 9,800 newtons. Right? That's the only thing pulling it back. So that is the net force. So then you know the force of friction, 9,800. We'll go back and we can kill this thing, 9,800. So take 9,800 divided by 24,500, and you get 0.4. So the coefficient is 0.40. Let's see, how many significant figures are we dealing with here? Looks like 3. 0.400? Yeah, because everything's got 3, so I can go 0.400. Tough problem.